Okay, section 2.2, part 2. Just a little section right now. So ideally you've already watched the creation of the periodic table video. If not, go back to Teams. It's linked in the stuff you should be doing for the week. Another crash course video. Really interesting look at kind of how the periodic table has sort of evolved and where its starting point was and that kind of thing. As far as the periodic table and how it's actually organized goes, periodic table elements are always listed in order by their atomic number. So remember from before, the atomic number is the number of protons in the nucleus. The metals are grouped to the left of the periodic table, and so it's like your left when you're looking at it. And the transition metals range from group 3 to group 12. And then any non-metals are on the right, and then the metalloids form a staircase toward the right side. So our metals, with the exception of hydrogen, which is just kind of a weirdo, are all to the left in this kind of purpley bluey color. Our metalloids, which are the things that have some properties that you would normally associate with metals and some that you would normally associate with non-metals, are the staircase separating the metals from the non-metals, and then ones on the green on the right are our non-metals. Information that's on it, we've already talked about this briefly. You've got your atomic number, or your proton number is up at the top generally. Our elemental symbol, normally nice and big, it may or may not also have the name underneath it, and then you generally get your atomic mass in AMU as well. Okay, we can talk about periods of the periodic table. It's the sort of fancy official name for rows of elements. So if you go across in a row, you're in one period of the periodic table. All of the elements in a period have their electrons in the same general area around their nucleus. So whatever row number you're in, that is equal to the number of rings or shells of electrons. Okay, so you can kind of see this here. Period 1 has 1 shell, and period 2 has 2 shells, and period 3 has 3 shells, and period 4 has 4 shells. Those are looking at 4 models. Should have looked at those last year in Science 9. If not, we'll do a refresher on them coming up. Columns of elements, so the rows are periods, the columns are considered to be either groups or families. Elements within a family have similar properties, and then they bond with other elements in similar ways. Okay, so they have similar both physical and chemical properties generally. Group 1 or family 1 is the alkali metals, so that's this one right here. Once again, ignoring hydrogen because it's kind of a weirdo. But anything in orange here is your alkali metals. Group 2 are your alkaline earth metals. So that's 1. You can see the little 1 there and the little 2 there. Group 17 is the halogens over here. And in group 18, the noble gases over there. Okay. We generally don't talk about any other groups or families because that consistency within properties and traits doesn't hold up quite as well outside of those 4. There's definitely still similarities, but they're not quite as glaringly obvious as they are in those 4. Okay, so looking at a periodic table, you should be able to identify kind of the following things on it. So you should be able to pick out where the atomic number is on any one of these elements. You should be able to pick out what a period is on this. You should be able to identify groups and families. You should be able to identify where metals versus non-metals are, as well as transition metals, metalloids. And then the specific families that you do need to be able to identify are the alkali metals, the alkaline earth metals, the halogens, and the noble gases. So we don't assign names to any of the other families, but you should know what those 4 are. You should know where to find them. And as we get further into it, you should be able to identify some general properties of them. For example, alkali metals, most reactive metals. Halogens, most reactive nonmetals. Noble gases, least reactive elements on the entire table. Okay,